Question 14 about polynomial questions. They give you a polynomial with some unknown coefficient. And then they say that when this function, power of 4, divided by x plus 2, and its remainder, and the situation when px is divided by x minus 2, that remainder are the same. This is the first information. So, first information is given R1, the first remainder, is equal to R2, the second remainder, while the first remainder is when px divided by x plus 2. The second remainder is talking about when px divided by x minus 2. So they say that in this situation, this remainder and this situation, this remainder, they are just the same. This is the given information. And then furthermore, they say that px, they give you px in this format. And other point, they also give you px in the factorized format, which means that these two are just simply the same thing. That means it is identity. So the second thing is 6x power 4 plus 7x power 3 plus ax squared plus bx plus c are identity. Another format is like this. And then we try to further elaborate part by part, then it leads us to the answer. Just from the left hand side first. When px is divided by x plus 2, which means this is p, we put a suitable x to make the divisor become 0. We put negative 2 inside. And it's the same as p, similar reason, but this time it's positive 2. And then we further elaborate it by using this one. And then you will find out that the even number power will finally cancel out, because negative 2 even power is the same as positive 2. So we both have, both sides, we have 6 to power of 4. That's why this one can be a null. So that's why this is a null. This pair is a null. And C is a null also. Only 4 terms are left in this equation. It makes it much easier. So we have negative 56 minus 2b is equal to 56 plus 2b. Negative 28 is the value of b. So this information just give us the value of b, and then we are going to apply it to the identity here. So for this information, we are going to work on right hand side. This format is favorable to compare term by term already, so our focus is to evaluate, expand right hand side, and our target is to group them tidily like this, so that we can compare their coefficient one by one. So we focus on right hand side of the equation. Is equal to Lx squared times the bracket plus 5x times the bracket plus 8 times the bracket. Again, make your hand busier than your brain. Use some method will reduce your brain burden to avoid any careless mistake. And only one equal sign for each calculation. And also leave some space between term by term. And then we can compare with our left hand side. We just copy down for easy comparison. For identity, like x power 3 plus 2x plus 5, if we say that is identity to something, then that must be exactly x power 3, exactly 2x, exactly 5. So that's the criteria and the property of identity. So we know that 2l is equal to 6. And this coefficient together, lm plus 10 times, is equal to 7 times here. Therefore, we are going to use some logic called by comparing coefficient. We know that first 2l is equal to 6. Second, we know lm plus 10 is equal to 7. Third, we know that lm plus 5m plus 16 is equal to a. Also, we know that 5n plus 8m is equal to b. And then finally, we know that 8n is equal to c. Among these 5 conclusions, may not everything useful. It depends on what you need. We need L here, and it's only unknown, so we can easily solve it. L is equal to 3. After we know L, then only M is unknown here. Then we can solve this equation also. So 3m plus 10 is equal to 7. M equal to negative 1. The third finding here is not very useful, even though it's helped us to get A, but we are not asked anything about A, so we may just ignore it here. Our focus should be N. That's the only unknown we didn't get. And then we have 5N. N we know that already. B we also know that already, so we can solve it. To conclude, in part A, that means we know that L is equal to 3, M is equal to negative 1, and N is equal to negative 4. In part B, they ask about equations, and then we want to know the roots of this equation. Is there how many of them are real? That's the question. So we should start from here, start from the equation. Sometimes it may not the function directly equal to 0. So every time we just make sure we use this. After that, we are going to write in this format or this format. But in order to solve an equation with higher power than 2, then of course we prefer the factorized format. So we should use, and one of the reasons is we get LMN in part A already, while part A they didn't ask anything about ABC directly. So we use the result 3x squared plus 5x plus 8, 2x squared minus x minus 4 equal to 0. So something times something equal to 0, which implied by the zero product rules. Either the first factor equal to 0. If not, then another factor equal to 0. Otherwise, it's impossible for the product equal to 0. And then we are going to consider how many roots here. We are not really want to know what is the value of roots. So that's why we just use our very quick test indicator to check how many real roots here. We use delta. So this delta is more than 0, then we can make the conclusion is we have no real roots in this part of the quadratic equation. And then the second part, in the second quadratic equation, we do the same thing. We use the indicator to see how many real roots here. which is larger than 0. Therefore, there are two different real roots. And the questions is asking about px equal to 0. So not only this part or this part, we are talking the whole equation. We have no real roots here and we have two real roots here. So in total, we have two real roots. Then we can draw the conclusion. To solve this type of equation, just simply don't forget that whenever you are going to solve an equation with higher power than 2, that means cubic polynomial or power of 4 polynomial, you just simply use your own method or by the hints in the question to factorize it. After that, we just simply use zero product rule to downgrade the polynomial to be quadratic or even linear. Then you can solve it by what you have learned.